Hello everyone. Am I audible? Hello.
Yes, sir, you are audible.
Yeah, okay. So let's just wait for a few minutes so that more people can join and then we can start. Hello. So myself Sanjay Sarkar. I am a PMRF fellow and I am from IIT Kanpur. I am pursuing PhD. I am currently in third year of PhD. I am pursuing PhD in condensed matter physics. So I am going to solve few questions today, as Professor Amal Kumar Das has already taught few classes, I think, from the first chapter. So before starting, let's just introduce ourselves. So can we just can you people just turn on your mic and say your name and what is your degree, what degree you are pursuing? Then it will be easier, like to. Am I audible? Hello.
Yes, sir. Audible, sir.
So can I know what degree you are pursuing currently? Just to get the
Yes, sir.
idea of the audience, oh, what are they doing? Even if you want to, you can type in the chat also.
Sir, good evening, sir.
Sorry.
Sir, good evening, sir.
Good evening.
Sir, only name okay, sir, or otherwise ID number, sir?
Name and your what degree you are pursuing, like undergraduate, postgraduate, BSc, MSc, or from engineering background, to get an idea.
Faculty means a designation enough, sir.
Yeah, yeah,
Yeah, okay, sir. Sir, yesterday session discussed or not, sir?
yeah. There was an session yesterday also. There was some another TA.
I think yesterday link not connected, sir. Today only connecting. That's
Oh,
only I am having doubts, sir.
okay, I'm not sure, but I think there was another session
I
yesterday.
am waiting from 6 to 7 o'clock. Up to 1 hour I am waiting, sir. But still now not connecting the Google Meet link, sir. Today correct time connector. That's only I have doubt. But my side is any problem or otherwise yesterday not discuss about anything, sir. That's only I am asking. No problem. Thank you, sir.
Yeah, yeah. I'll inform about the link not getting connected. But yeah, so
Okay, then. Thank you, sir.
okay. So people are still joining. So uh, let me just wait for 2 3 more minutes. Let's. So basically, this course was offered for undergraduates. So assuming that the crowd here is mostly from undergraduate, I'm going to solve few basic questions. So starting with, so let me open my. Okay. Let me share from my iPad. There should be an option, right? Entire screen. What is wrong with this? What is it? Mm, Give me just a couple of minutes. I want to share it from my iPad. Wait a minute. Why can I can't I share? happening? I don't know why I can't share from my iPad. Let me check again. Does anyone know how to share from an iPad? Like I want to share my screen from iPad, and it's showing that there is something, some error is there. Do I need to give permission here? Send reaction, turn on caption, activities, host controls. Okay, share their screen. List your. I have given permission to everything. Share their screen. Okay, now I think it will. Okay, let me check again. Okay, what's happening? Sorry for the delay, but if I can't share my iPad screen, I can't do anything. Just 1 minute. Silent. Still don't understand it. Can I write here? So this is the question paper I want to solve. Is my screen visible? So I wanted to solve it in iPad, but I don't know what is happening.
Sir, your screen is visible, sir. You proceed.
Yeah, so it was a previous assignment from this course. So I wanted to solve these questions only. So as the first question is written there, can you read from the screen? Hello? Hello?
Can I read the question, sir? First question.
Can you read the questions from the screen?
Yes.
Is it clearly visible?
Consider. Yes, it is visible, sir.
Okay, okay.
Consider the
So
physical constant.
yeah, yeah. So I want you guys to first to try these questions, and if you can't solve, then I'll take over it. So first, you guys try, and let's see how you approach the questions. and let me know which of the options is correct. And meanwhile, I also try to share the screen here. If anyone can solve this, then let me know, please.
Rejoin guys.
Rejoin किया अभी still not working. I wanted to share my iPad. Otherwise मैं कैसे solve करूँगा, एक भी क्वेश्चन solve नहीं कर पाऊँगा.
Just do it once.
Sorry,
एक बार दोबारा कर काट के.
इसको मैं कर दूँ, मतलब निकल जाओ इससे, निकल गया. यहाँ से ज्वाइन कर सकता है क्या? ज्वाइन मेरा कोड तो मुझे नहीं पता, बट आई नो द लिंक. यहाँ पे डाल दो.
कोड ही होगा ना.
न्यू मीटिंग.
ये नहीं होगा.
कोड तो नहीं है मेरे पास में. यहाँ से ज्वाइन कर सकते हैं. यहाँ से बोल रहे हो गूगल में नहीं जा रहा है, पता नहीं क्यों.
हेलो.
प्रेजेंट, अगर प्रेजेंट करो तो क्या दिखाएगा? I don't know what's happening.
इसको रिफ्रेश करो एक बार.
इसको रिफ्रेश करो, कहाँ से करो रिफ्रेश?
Let me switch it off and switch on.
Don't understand what's happening. Do I need to give access here? Has anyone solved this question yet? You need to use the formula of Bohr radius and the velocity in the orbit, Bohr orbit of hydrogen atom. Then you can find the time t. You need to calculate t. So t is 2 pi r by v. If you know r and v, then you can calculate t, right?
इसको एक बार switch off करके switch on करो.
I don't think that will be a problem. इसमें टाइम लग जाएगा.
नहीं लगेगा. कितना समय लगता है? No, I'm just saying just make it switch off completely. Yeah, and then switch it off. Anyways, it is taking time, so let's do it.
On करो फिर से.
Try to explain first question.
Sorry.
Try to explain first
nobody could solve this problem. This is a class 2 level question, right? People are joining so late. It's already 5:22. So to find the bore radius, you know that the centrifugal force is provided by the electrostatic force. So you need to equalize. So since I can't use my iPad, I'm just saying you can write it down. So the formula will be mv square r, mv square by r equal to 1 by 4 pi epsilon naught into e square by r square. So this is one formula, and there will be another one, which is the Bohr model is the angular momentum mvr is equal to nh bar. For the first orbit it is h bar. So from these two formula you can find out what is the radius, that is r, and you will see that the value of r will be 4 pi epsilon naught h bar square by m e square. And if you put this in mvr equal to h bar, then you can find v also. Now we need to find the time. So time t equal to 2 pi r by v. Now if we put the formula of r and v in the formula of t, then you will see that the formula will be in terms of m, e, h and epsilon naught, and all the constants are given in the questions. Then if you put all the constants, you will find that option B is correct. So I want everyone to do this question. Everyone understood what I have told just? Or is it too trivial? Come on, you guys need to respond at least, otherwise how will I proceed? Even in the chat, if you don't feel comfortable talking, you can write in the chat what answer did you get and how did you solve. Yeah, so here it was asked that consider the physical constant given below and calculate the time taken by the electron to revolve the first Bohr orbit of hydrogen atom. So you need to calculate the time period t, which is given by 2 pi r by v. So r is the radius of this Bohr orbit, and v is the velocity when the electron is traveling in the Bohr orbit. So you from the Bohr model you can calculate the radius of this Bohr orbit and also the velocity. So to calculate this r and v, I said that you need to use that two equation. You will see that there will be two equation, and from these two equation you can find r and v both. And if you put these two in the formula of t, then you can find that time period, and it will be option B. It would have been easier if I could show in the iPad. I don't know why it is not allowing me to share. I can check one more time. Let me check this. यार कुछ तो करो यार, ये क्या कर रहा है उधर? मैं नहीं शो करूँगा तो कुछ नहीं समझ में आएगा इनको.
How can I find the board at least?
I used to do it in मैं सारे शेयर वगैरह करके तुमसे किया.
कोड है कोड
मीटिंग का कोई कोड नहीं है, मीटिंग लिंक कर रहा
लिंक किसने किया है ये जल्दी
मैंने
लिंक
जनरेट किया,
तो कौन
लिंक से
होगा?
जनरेट किया, लिंक से जनरेट किया था मैं अभी जनरेट किया मैंने।
वो कॉपी वाला है तो इमेज कैसे शेयर किया जाता है?
मैं ऐसे करके कॉपी कर लिया। मीटिंग शेयर कर सकते हैं।
तो फिर मैसेज शेयर करोगे क्या करेगा लिंक नहीं शेयर करो
This was the link, right?
वाले मैसेज को डिलीट कर सकते हो
ये नहीं था ना?
ये नहीं इट्स डिफरेंट
But this is the solution. That's the problem.
कॉपी कर लेना कोई बात नहीं यहाँ से कॉपी कर ले Get, हाँ बाकी ऊपर वाले डिलीट करते रहना
That was the link, right? Hello. I have sent a Google Meet link in the chat box. Can you join that link? I mean, I can share that link. How do I remove this?
क्या हुआ
How do I remove this? Share screen. Let's see.
go to switch
Join to that link. I'll also join this link. Because there I can like share things.
कि मैं कब बंद कर रहा हूँ ये लिंक सबके लिए एंड कर रहा हूँ मीटिंग दूसरी मीटिंग में शिफ्ट हो जाता है And then
So
just
I am also leaving this meeting. Just go to that link, and there is another Google link I have shared. So I am ending this meeting. I think here you can see my screen. Now I can write whatever I want to.
You are on. Also open the question paper.
Hello. You can see my screen here, right?
Yes, it is.
Yes, sir.
Sorry. So could you solve the first question? Let me write down the question and I'll solve it. Consider the physical constants given below and calculate the time taken by the electron to revolve first Bohr orbit. For the record, I am also writing the question so that when I send this document, the question is also there. Orbit of hydrogen atom. So options are given as let me write it in another red color. 4.12 into 10 to the power minus 12 second. Option D 1.51 into 10 to the power minus 16 second. 9.10 into 10 to the power minus 19 second, and option D is 1.71. Can you read the whatever I am writing? Can you read?
Yes.
So did anyone solve this question yet? Or else I can solve it. So since the electron is in hydrogen atom, electron is moving in the first Bohr orbit. So for any circular motion, we know that the centrifugal force is provided by any another force, and in this case it is the electrostatic force. In SI unit, this is 1 by 4 pi epsilon naught into E square by R square. So one relation is there, this is equation 1, and there will be another relation. According to Bohr model, we know that the angular momentum mvr is constant and it is n h bar. So for the first Bohr orbit, n is 1, so it will be like only h bar. So this is equation 2. So from solving equation 1 and 2, we will get the expression of r. So let's substitute v. So from here we get that v equal to h bar by mr, right? So if we substitute this in equation 1, then we will get m by r into v square is h bar square by m square r square. That is equal to 1 by 4 pi epsilon 0 into e square by r square. So this r square cancels out, and here m square, there will be only one m. So from this equation we get that r equal to, so let me write one more line. Okay. Yeah, so from here we get that h bar square by mr equal to e square by 4 pi epsilon naught, which implies that r equal to 4 pi epsilon naught h bar square divided by m square. So this is what we get as the first bow radius. Now if we substitute the value of r, this is r. Now if we substitute this in equation 2 or equation 3, then we will get the value of v also. So v equal to h bar by m, and r is given as 4 pi epsilon naught h bar square by m square. So m cancels out and there will be 1 h bar here, so we'll get e square by 4 pi epsilon naught h bar. So this is v. Now we know that time period t is calculated as t equal to 2 pi r divided by v. So 2 pi into, now r and v both are known, so this is v. So if we substitute the expression of r and v here, we'll get what will we get? 4 pi epsilon naught h bar square by m square into v is 1 by v is 4 pi epsilon naught h bar by e square. So from here I think I have done something wrong here. Is it so? No, everything is fine. So 32 pi cube epsilon naught square h bar cube divided by m e cube. Right, now all the constants are given in the question. So if you see the question, the value of all the fundamental constants is given, equal to 1.6 into 10 to the power minus 19 coulomb. Then electronic mass m is given as 9.1 into 10 to the power minus 31 kg. Then Planck's constant h is given as 6.6 into 10 to the power minus 34 joule second. And c is also given. I don't think c is needed here. And epsilon naught is equal to 8.86 into 10 to the power minus 12 coulomb square by Newton meter square. So you need to put these constants here. Now we also know that h bar equal to h by 2 pi, so remember that. So then if you put all the constants in this expression, t's expression, then you will find that t equal to 32 into pi cube into epsilon naught, which is 8.86 into 10 to the power minus 12 whole square, and h bar cube is h cube by 8 pi cube. So h cube is 6.6 into 10 to the power minus 34 cube divided by m is 9.1 into 10 to the power minus 31 kg into e cube is 1.6 into 10 to the power minus 19 coulomb into 8 pi cube. 8 pi cube because h bar is equal to h by 2 pi. So this pi cube gets cancels out and it will be 4. And then if you calculate, it will be 1.51 into, okay, someone wants to join, yeah, 10 to the power minus 16 second. So option B will be correct. Yeah, for this question option B will be correct. Sorry. So this is our right option. So does anyone have any doubt about this question? I think it is a plus 12 level question, plus 2 level question, so it should not be difficult to solve. Still, if you have any doubt, you can ask. And everyone please solve the question along with me. So moving to the, if you don't have any doubt, then we can move to the second question. We are already 5:45. So the second question, let me first write down the question. I'll write it in red color, maybe that will be better. Okay. So the second question is, how much energy is needed to excite so people how much energy is needed to excite an electron from the ground state n equal to 1 to n equal to 4 level of hydrogen atom. And the options are (12.75 electron volt). Option B is 13.60 electron volt. Option C 0.85 electron volt, and option D is 11.12 electron volt. So can you guys solve this question and let me know the answer? The question is visible, right? And also I wanted to ask one thing, did you guys receive any assignment yet? Did you guys receive any assignment, the first assignment? Because the first set of lectures are already given, I think the assignments will be given also. I don't know. Okay, so is these questions are in the assignments? I don't know. This was the 2014 questions, so I picked up this assignment. I thought these assignments will not be there. Okay, fine then. So solve this question. But don't waste too much time. Let me know if you can solve, and if you don't, then also I'll solve it immediately. Anyone solving this question. If you find the answer, then please write in the chat, or you can turn on your mic and say. This should be another easy question. So since time is running out, I'll solve it. So in the question was that how much energy is needed to excite an electron from the ground state to n equal to 4 level of hydrogen atom. So you know that for hydrogen atom, the energy level En is given as minus 13.6 electron volt divided by n square, where n is the energy level. So when the electron is the first ground state, that is n equal to 1, so E1 will be minus 13.6 by 1 square, that is 1. So 1 electron volt, and that will be minus 13.6 electron volt. This is the ground state energy we all know for hydrogen atom. And similarly we can calculate the excited state energy corresponding to n equal to 4. So for n equal to 4, we get E4, which is equal to minus 13.6 divided by 4 square electron volt. So this will be, can you calculate and tell me? Wait, let me calculate. Can you tell me what is the answer of this? 13.6 by 4 square, there is 16. So minus 0.85 electron volt. Now the question was asked that how much energy is needed to excite an electron from the ground state to this state. So the excitation energy equal to E4 minus E1. This is the amount of energy needed, that is 0.85 minus, so 13.6 electron volt. So it will be 12.75 electron volt. So option A is correct here. So this option is correct. So correct option, the correct answer is option B. So I think this was also an easy question. Does anyone have any doubt about this question? You just need to know that what is the energy level for hydrogen atom. So for hydrogen atom, since there is only one electron, this is our energy level, and using this formula you can calculate for any energy, you can calculate the excitation energy to excite from ground state to any other state. So I assume that there is no doubt about this question also. So we'll move to third question. Some people has joined now, so yeah, so some people has just joined. So if anyone have any question regarding these two questions I already solved, you can ask here. Or else we'll move to the third question. So I'll come back to this question later maybe. So let's solve this question. So question number 3. So if the potential energy function for a solid crystal is expressed as u r equal to minus a by r to the power 6 plus b by r to the power 12, then find out the potential energy of the crystal at equilibrium separation. At equilibrium separation, the attractive and repulsive forces between two atoms in solid becomes equal. So this is the question. Can you solve this question? Meanwhile, I can write down the options given here. So you guys try the question. Minus a square by 2b. Question B is minus b square by 2a. I think this question was also appeared in a previous year question of gate or net. I do not remember properly, but yeah. So this kind of questions can appear in gate or net. Minus a square by 4b. And option D is minus 2a square by 3b. Yeah, so this is the question. I want you guys to solve this question for. Let me know if anyone has solved it. And may I know which course or which degree you are pursuing? Can someone tell me? So that I can choose the level of questions, for example, Abhijit Dash. Abhijit, can you say what degree you are pursuing currently?
Yes, sir. I am a fourth year student in the Department of Electronics and Communication Engineering from IIIT DMG.
Okay. Thank you, Abhijit. So mostly, I guess, mostly there are only undergraduate students are here. If anyone solved this question, then write down the answer in the chat box if you don't want to speak. like if I just solve, then it will not be helpful for you guys. You guys first try, then face the difficulties, and then I will solve. And these questions are very trivial actually to solve. There will be more difficult questions coming up. So shall I solve this question, or you need more time to solve it, or you don't want to try? Well, I am solving this question then. So the question was that if the potential energy function for a solid crystal is expressed as u are equal to minus a by r to the power 6 plus b by r to the power 12, then find out the potential energy of the crystal at equilibrium separation. At equilibrium separation, the attractive and repulsive forces between the two atoms in solid becomes equal. So someone is saying option D. Yuvarani is saying that option D is correct. So let's solve this and check if she is correct or not. So at equilibrium, let's first write what is u or minus a by r to the power 6 plus b by r to the power 12. So we know that at equilibrium this dr du dr, r naught is the equilibrium distance, then this will be 0. So it is like if we derivative this 6a by r to the power 7 minus 12b by r to the power 13 is equal to 0, which is equal to 6a by r power 7 equal to 12b by r to the power 13. So r to the power 13 by r to the power 7 equal to 12b by 6a, which implies that r to the power 6 equal to 12, so 2b by a. So we need to calculate what is the find out the potential energy of the crystal at equilibrium separation. So we need to find what is u at r equal to r naught. Okay, we are calculating this at r equal to r naught, so everything will be r naught. So r naught to the power 6 equal to 2b by a. So if we calculate this at, so minus a into r naught to the power 6 will be 2b by a, so a by 2b plus b into r to the power 12, so it will be a square a by 2b whole square. So this is minus a square by 2b plus a square by 4b. So the option will be a square by 4b. So minus a square by 4b, sorry. Was it option here? Yeah, I think option C is correct if I have not done anything wrong here. Option C is correct option. Did I do any mistakes here? Or option C is, you are also getting option C, because someone said option D is correct. Can anyone say if someone has calculated this? Because I am getting option C as the right option. The correct answer is option C. Or you can also write in the chat box if anyone disagree with this, then you can write this in the chat box, because someone also getting option D as the correct option. So that's how you need to calculate it. You need to first these kind of questions arrives in like GATE, NET, any kind of competitive exam. So this is the trick. You just need to derivative it with respect to r, and then put it as 0, find out the equilibrium distance, and then put it in the potential expression. So for this question I have got that option C is the correct option. I think there is one more question like this one which we can try to solve. Let me find out if it is solved. Yeah, I have found this question. So there is one more question like this one. This is also an easy question to solve. Question 4. So do you have any doubt or any question about this previous question, question number 3? If not, then I want you guys to solve this question, question 4, because it is almost similar to that the previous question. The potential energy function is expressed as u r equal to minus a by r cube plus b by r to the power 7, and find the distance, r naught at which the potential energy will be minimum. So this is exactly like the previous question, just the potential is different. So at least solve this question. I want answer from everyone for this question. Within 3 minutes, maybe 3 minutes is enough for solving this question. By 7. Option B is 7 by 3a equal 1 by 4. Option C is 7a by 3b 1 by 6. Option D is none of the And also, can you guys confirm that these questions are not in the first assignment you are given already? Can anyone say that these questions are not in the first assignment? Come on, you have to reply, otherwise I will communicate.
Actually, sir, I haven't yet like done that assignment. I don't know.
Okay. So can you solve this question, question number 4?
Yes, sir, trying.
Okay. option B. Okay, someone has thought as option B is the right option.
Yes, sir, option B.
Okay, so since more people are saying that option B is correct, I'm assuming they are right. So this is also a straightforward question. So UR is given. It is exactly similar to that previous question. By r to the power 7. So you need to first derivative this with respect to r at the equilibrium position. The energy will be minimum at r equal to r naught. So for minimization condition, it will be 0. So you need to find out the r naught, the distance. So it is easier than the previous one. So this implies that 3a by r to the power 4 minus 7b by r to the power 8 is equal to 0. r naught, yeah. So r naught to the power 8 divided by r naught to the power 4 is equal to 7b by 3a. So this is equal to 7b by 3a, which implies r naught equal to 7b by 3a to the power 1 by 4. So option B, yes, correct option is option B. So the correct answer is option B. So I don't think anyone should have any doubt about this question. This is straightforward. So moving forward to the next question, we will solve this question. Yeah. So let me write down the question first. So this was question number 4. So question number 5 is, how many unit cell cells are there in 1 gram of NaCl crystal? Consider in each unit cell in each unit cell of NaCl crystal having 4 molecules of NaCl, and it is given the molar mass of NaCl is given 58.5 gram, and Avogadro's number is also given, which is Na is given as 6.02 into 10 to the power 23. So these data are given. So you need to calculate that how many unit cells are there in 1 gram of NaCl crystal. Consider in each unit cell of NaCl crystal having 4 molecules of NaCl, and molar mass of NaCl and Avogadro number is also given. So you need to calculate how many unit cells are there, and the given option, 4 options are 3.21 into 10 to the power 20. Option B is 2.57 into 10 to the power 21, C is 6.93 to 10 to the power 23, and option D is, we'll see, we can move it from and option D is 9.73 into 10 to the power 25. So these are the four options for this question. You guys first try and then I'll solve this question. कराना पड़ेगा 2 घंटा तक. Could anyone solve this question? Option B, yeah, someone is saying option B is right option. So let's try this. So molar mass is 58.5 gram. So in we can find that in 1 gram NaCl, how many moles are there. So in 58.5 gram there is 1 mole. So in 1 gram will be 1 by 58.5 mole. So if we calculate this will be, can we find it out? If you have calculator, you can calculate it and tell me. 1 divided by 58.5, right? So 0.017, or we can write this like this also. So this mole, and how many molecules this many moles contain. So 1 mole molecule, in 1 mole we have 6.02 into 10 to the power 23 number of NaCl. This number of NaCl. So in 1 by 58.5 mole we'll have 6.02 into 10 to the power 23 divided by 58.5 number of NaCl. So this number of NaCl. Now in the question it was said that how many unit cells are there in 1 gram of NaCl crystal. So you know that in each unit cell there will be 4 number of molecules. So the required answer, that is the number of unit cell, will be 6.02 into 10 to the power 23 divided by 58.5 divided by 4, because in each unit cell, let's say in each unit cell there will be 4 initial molecule. So the required unit cell will be, to calculate the required unit cell you need to divide by 4, and the answer will be, so 6.02 divided by 58, 58.5 into 4 into 10 to the power 23. So 2.57 into 10 to the power 21. This number of unit cells is needed, and the right option will be option B. Yes, the correct option is option B. So I think Dhanush said that option B is correct, so he is exactly correct. The correct option is option B. Anyone have any doubts about this question? If we don't have any doubt, then we'll move to the next question. Okay, so we'll move to the next question. Yeah, this is another question from class 2 level. This is also very easy question. In an atomic structure, sorry, is it question number 7? Is it question number 6, right? In an atomic structure, maximum how many electrons can be put filling from the lowest filling from the lowest energy up to principal quantum number n equal to 4. So you'll have to calculate the number of electrons that can be filling from this from the lowest energy up to the principal quantum number n equal to 4, and the given options are A equal to 32, B equal to 30, C equal to 50, and D equal to 60. So this question I expect you guys to solve, and meanwhile I will charge my iPad because the charge is only 4% charge is remaining. So let me charge for at least 3-4 minutes, and you can solve this question meanwhile. Someone is saying option A, so read it properly. So how many electrons can be put filling from the lowest energy up to the principal quantum number n equal to 4. So you have to add all of these electrons. calculated it yet. I think option D is 60 and not 6. Wait, remember. So as you can see that the maximum number of electrons that an orbit can, so you have four quantum numbers for an electron. Principal quantum number n, which can take integer values from 1 to 3, and it is the energy level of that particular electron. And there is another three quantum numbers, azimuthal quantum number L, which determines the shape of the orbital, and it takes value from 0 to n minus 1. Then there comes the magnetic quantum number, which is M, which determines the orientation of the orbital, and it takes value from minus L to plus L. And then there is spin quantum number, which takes plus half and minus half for electron. So in this case n is given, so the principal quantum number is given, and we know that for a shell the maximum number of electron that can be there is determined by the formula 2n square. So it says that starting from the lowest energy up to the principal quantum number n equal to 4. So we need to consider all of these energy shells. So for the first energy shell, we have number of electrons is 2 into 1 square, which is 2. And for the second shell, that is for n equal to 2, the number of electrons will be 2 into 2 square, which is 8. Then for n equal to 3, we'll have 2 into 3 square, which is 2 into 9, that is 18. And for n equal to 4, we'll have 2 into 4 square, that is 32. So if we add all of these to 8, 18 and 32, we'll get 60. So the correct option will be option D, that is in an atomic structure maximum how many electrons can be put filling from the lowest energy up to the principal quantum number n equal to 4. So you need to consider from n equal to 1 to n equal to 4 and add all of this. So option A is not correct. I think for this option D should be correct. Someone else also said option A is correct, but yeah, why do you think option A is correct, even if it is says that electrons can be put filling from the lowest energy up to the principal quantum number n equal to 4? Shouldn't it be option D? Can anyone explain, whoever is thinking option A is correct? Hello. Let's say for Vaishali, Priya, Kalpana, they are saying option A is correct. But yeah, if it was asked that number of electron in the principal quantum number n equal to 4, then it is option A. But it says from starting from the lowest energy to the yeah, someone.
Sir, I will put 2n square. The n square n value is 4. That's why 32 is correct answer, I will say.
Okay, yeah, so if it was asked for that n equal to 4 level, then definitely it is 32, 2n square, that is 2 into 4 square, that is 32. But it says that read the question properly. It says that in an atomic structure, maximum how many electrons can be put filling from the lowest energy up to principal quantum number n equal to 4. So it,
Okay, sir.
yeah, so it would be 2 plus 8 plus 18 plus 32, and if we add all of this, then we'll get 60. Okay, so moving forward, well, we have another question similar to that potential question I can share it rather than writing it, since my iPad is charging. I'll share it here. It is there, yeah. Mm, yes, sure. Is this question number 5? Can you see my screen?
Yes, I do.
Yeah, can you solve question 5? I also did not solve it yet, but I think we can try it together. So meanwhile my iPad is charging. You guys can try and say if you can find the right option. iPad is charging. कितना चार्ज है? कितना? 11. फाइन, ये क्वेश्चन सॉल्व हो जाएगा फिर से बैठना। इधर बैठना थोड़ा मुश्किल हो जाएगा। Hello. Anyone solved this question yet? If you have, then please let me know. Meanwhile, I'll write the answer to this last question. So you know the maximum electron in a given shell or in a shell equal to 2n square. So for n equal to 1, it will be 2 into 1 square, that is 2. N equal to 2, it is 2 into 2 square, 8. N equal to 3, 2 into 3 square, that is 18. And n equal to 4, 2 into 4 square, so we'll get 32. So the total number of electrons will be 2 plus 8 plus 18 plus 32, which is equal to 60. So the correct answer is option D. Oh, sorry, I forgot to share my screen here. So let me share the screen first. This screen. So this is the answer of the last question. How do I make it? इस स्क्रीन को बड़ा करना है मुझे, इसको हटाना है, बस इस स्क्रीन को देखना है, तो क्या कर सकता हूँ? उल्टा पुल्टा कुछ मत कर देना फिर, इससे ये होस्ट कॉन्फ्रेंस एक्टिविटीज़ नहीं, इससे भी नहीं है. मोर ऑप्शंस, फुल स्क्रीन नहीं, इसमें नहीं होगा फुल स्क्रीन. ये बड़ा नहीं हो रहा है ना, फुल स्क्रीन कर दो ना. ठीक है, लेट इट बी.
इतना ही होगा ना वो.
हाँ ले, ठीक है. Can't change it. Oh, sorry, I forgot to write down the question also. Let me write the question of the. This was question number 7. Assuming the equilibrium separation of two atoms to be 2.8 angstrom and dissociation energy which will be given out in the process of the formation of a crystal by bringing neutral atoms from infinity to the position of equilibrium. Did anyone solve it? It's a pretty big question to write down also. Position of equilibrium or it is defined is defined as the energy required to separate the atoms from equilibrium separation to an from equilibrium separation to an infinite distance. Is 8 into 10 to the power minus 19 joule. Calculate the value of A and B in the expression of the potential energy U are equal to A by R to the power 9 minus B by R. So this was the question. It's a pretty big question, so I don't think it will be very difficult to solve. Did anyone solve it yet? The options are given as 6611.5 electron volt angstrom to the power 9. B is 15.75 electron volt angstrom. Similarly, B is A equal to 1122.7 electron volt angstrom to the power 9, and B is 13.24 electron volt angstrom. C is 8135. What I can do from the next class is I can write the questions which I want to solve beforehand to save time actually. There is one more is 9921.8 electron volt angstrom to the power 9, and B is 2138 electron volt angstrom. So these are the four options. So I think it was similar to the previous two questions we have solved of this type. First, let me read out the question. Assuming the equilibrium separation of two atoms to be 2.8 angstrom. So here R naught is already given in the question. So in the last previous two questions we have solved what is R naught, but here this R naught is already given. This is the equilibrium separation, and the dissociation energy, which is the energy which will be given out in the process of the formation of a crystal by bringing neutral atoms from infinity to the position of equilibrium, or it is defined as the energy required to separate the atoms from equilibrium separation to an infinite distance. So this energy is required to dissociate these two atoms. So this energy is equivalent to the energy, that is, if we want to solve this, we have to at R equal to R naught, this will be A by R naught to the power 9 minus B by R naught, and we already know what is R naught is. So, and this energy will be equal to 8 into 19.8 into 10 to the power minus 19 joule, because this is the energy at equilibrium, and the energy at infinity will be 0. If we put r equal to infinity, then this will be 0, and this is the dissociation energy is defined as the energy which will be given out in the process of the formation of a crystal by bringing neutral atom from infinity to the position of equilibrium. So at infinity this was this, and at position of equilibrium the energy is this. So the difference between these two will be this energy, 8 into 10 to the power minus 19 joule. So we have a minus sign will be there actually. This will be minus 8 into 10 to the power minus 19 joule. So if we put R naught, what is the value of R naught? 2.8. So from here we will get A by 2.8 to the power 9 minus B by 2.8 equal to minus 8 into 10 to the power minus 19 joule. Now this joule can be converted to electron volt because the options given are written in electron volt unit. So to convert this, we will divide this by 1.6 into 10 to the power minus 19 joule. This will be in electron volt unit. So to calculate this, 8 divided by 1.6, that is 5 electron volt. So in unit of electron volt it will be 5. And there is another condition. So this is equation 1. Wait a minute, this is 0 and the dissociation energy is energy. The another condition is that dy dr at r equal to r naught, which is 2.8 angstrom, is 0 because this is the equilibrium distance. So we have minus 9a divided by r naught to the power 10. R naught is 2.8, so I am putting this value minus plus b by 2.8 square equal to 0. So this is equation 2. So from equation 1 we will get 2.8 to the power 9, which is a by 10, 5, 7, 8 and 4 minus b by 2.8 divided by minus 4. This is option 1. And from the other equation we'll get 2.8 to the power 10, that is minus 9a divided by 29619.7 equal to b by 2.8 square, 7.84. So you can substitute any of these and you can find out the other constant. Let's say for if we substitute b, then minus 9 by 29619.7 into 7.84. So this is just mathematics. If you calculate it, you'll find 29619.7, sorry 29619.7 it will be 0.0023224a. If you substitute this in equation 1, you will get a by 10, 5, 7, 8.4 it is just mathematics which I am doing right now. So 0.0024 divided by 2.8 into a to minus 5. So you can take it out, and so 1 by 10578.4 plus 10024 divided by 2.8. I think I have done something wrong in the calculation. You can check the calculation. So this is the process. You can check the calculation and find out whatever the value is. So I don't think I have done it correctly. A into something into minus 5 into that. Well, let me check. A into 0.00095. So the value of A is 5 divided by this value. So 5 divided by 0.00095, which is given at 5263.15. Is there any option like this? I don't see any option like this, so I might have done something wrong in the calculation. So you can check the calculation, but this is the process, as you can see. Don't know where I have done the mistake. By 1.6. So you guys check the calculation. Maybe there was some mistake. If I go to there, then it will take some more time. So rather we can move to some another question. Or oh, it's already, yeah, it's already for 6:52. So I'll rather not take any other question. So in the next class we can discuss this question more. I mean, I'll check the calculation and you guys can also check the calculation. Did anyone already do it and find any right options? If not, then yeah, we'll check in the next class and see if the mathematics was correct or not. So before ending this class, I want to ask that what do you guys prefer, like more theory or more problem solving, or the balance between them? What do you want, like, to for me to discuss in this 2-hour session? So since it was the first session, I thought I will solve some basic questions. Does anyone have any suggestion or anything? Anything that will help you? Also, did you join the last session taken by Aishwarya? Maybe yes. It was yesterday, I guess. Yesterday evening from 6 to 8. Did anyone join that class? Can anyone answer? Acha, no. Acha, no one has joined. Okay. And whatever I discussed, was it like understandable to you, or do I need to slow down, or do I need to fast things up? Well, do you have any doubts about these 7 questions I have solved today? Though the last question was not solved properly, the mathematics I need to check again. So if anyone has any doubt, you can ask now about any of these 7 questions. Starting from the beginning. Is my screen visible? There was a comment that my screen is not visible. So there is theory as well as mathematics. So physics is without mathematics you can't do physics. So definitely there are theory, but solid state physics is I guess I'll say that it's a balance between both of them. There is theory, there is mathematics. Without mathematics you can't do physics. But there are plenty of theories, like starting from crystal structure, then there will be superconductivity, which is very interesting. Then transport theory, definitely there are so much theory there. It's transport theory. So Vetri Selvi, what degree you are pursuing? You are undergraduate or postgraduate? UG. Okay. So if you have physics background, then it will definitely need it. Okay. So there are PG students also. Okay. So if anyone has doubt, you can still ask, or else we'll end this session after 2 minutes maybe. And about this,
No doubt, sir.
okay. So if someone doesn't have any doubt, you can leave the session, because I will not solve any other question today. This question is remaining, yeah, that will be solved in the next class. So otherwise I'll just leave in 2 minutes.
No, just tell them only, no?
Yeah, still okay.
We are ending this session.
Thank you, sir.
Yeah, thank you everyone for joining. I will see you guys in the next class. Thank you for joining. Yeah, again. So let me stop this session if there is no doubt. There is no. Someone is raising hand. Is there any question, or is it mistakenly? So thank you guys. I'll leave then. Bye. See you in the next session.